Good morning, guys. Samithya, good morning. So let us wait for a few minutes. Okay, let us get started. So कल हमने इन्वर्टर के बारे में सिंगल फेज फुल ब्रिज इन्वर्टर के बारे में डिस्कस किया था। उस समय लोड है ना, रेजिस्टेंस के लोड डिस्कस किया। When RL load is or RLC load is loaded, so how the behavior will be. Moreover, the diodes which are connected parallel to SCRs are called as a feedback diodes. Those are not into action yet. उसका use क्या है? Let us see that. So with R, RL, RLC load. R load ये वाला हो गया, but let me show it to you. So इसका picture क्या है? Circuit कैसे connect करना? There is a supply Vs and output voltage. Output voltage is plus V0 and current. I0 is the current here now, right? Now T1, T2 on resistance load. As soon as T1, T2 is on, this conducts. No other device will conduct. Yesterday I have shown you that is V0. Not only for that V0 waveform, for all loads here, not only just for plus Vs, not only for our loads, for all loads, RL, RC, RLC, conduction तो वैसे ही जाना चाहिए. So voltage will be same. which is a rectangular nature. Let's keep on going here now. Who is conducting eval period? I would say here now T1, T2. For R load, and this one is T3, T4 for all load. Next one is showing that I naught, for example, for R load, there is no change. V naught by R, only you can see the same waveform. This is I naught, resistance load. Yesterday we have discussed. What is happening to the RL load here? Let us see here. RL load. First of all, RL load, this is DC and you are getting AC here. No, RL load में क्या होना चाहिए? I'll tell you one concept. Voltage इधर है. Voltage मतलब इधर start हो रहा है. Or somewhere here now. There is a maximum. Somewhere the voltage is getting started. So current is lagging the voltage by some angle. That way I can start the experiment. Then I'll give another explanation later. So voltage इधर चालू हो गया, तो current will be kind of somewhere here now. It starts for RL load. So meaning, let me extend this. And RL load, DC is given to RL load. The current is kind of exponentially increases scenario. We know that one. Something like here now. RL load हो तो क्या होगा? This is what I was talking about. T1, T2 conducts. And this is R, L. So T2 here now. This is what happens. Vs, T1 इधर है, T2 इधर है. Okay. And this is RL load. So it depends upon the magnitude of inductance components. The current will be kind of lagging in nature. And you can see here now it starts from here on. Explanation. Yes, it goes here now. Now T1, T2 इधर conduction है. लेकिन इधर क्या होगा यार? आपने क्या कर रहे हैं? Gate signal T3, T4 को दिया. What you have done is gate signal. If you want to draw the gate signal also, so either forcefully, this is the one you can see. Gate signal is this is the point where gate is given to what? T3, T4. Gate signal is given to T3, T4, meaning T1, T2 turn off हो जाएगी forcefully. T1, T2 turn off क्योंकि signal हटा दिया मैंने. It's a base drive elements, not at the actual SCRs. The T3, T4 को trigger कर दिया, लेकिन T3, T4 will not conduct. Base drive दिया, T3, T4 will not conduct. So what will happen here? So it happens so that ये वाला current है ना same direction में, left to right में जाना चाहिए, positive current. Previous it was T1, T2. So now it is passing through same direction में जाना चाहिए. RL load है. Forcefully it is finding D3, D4. Previously the current is going like this. Now the current ये दोनों बंद हो गया, लेकिन current continuous होना चाहिए, current होना चाहिए here. So what will happen here now? Same current will go. इधर नहीं जा सकते क्योंकि opposite direction में. ठीक है? So only option I have is D3. Counter partner कौन है? इधर नहीं जाएगा, इधर जाएगा, इधर नहीं जाएगा, इधर नहीं जाएगा क्योंकि सेम लग गए. So D3 and D4. समझ गए ना बात? So D3 D4 here now. So this can decreases once you're already T3 T4 turn on है. D3 D4 conduction मतलब complete हो जाएगा D3 D4 current. Once this current becomes zero here now, since we already having the T3 T4 trigger, right? So then the current is going negative direction. Negative direction means opposite direction में जाएगा. This is our T3 T4. Look at this one. T3 T4. This is T3 T4 negative है. लेकिन क्या है इधर तक T3 T4 जाएगा cool. लेकिन क्या है इधर है ना पॉजिटिव वाला T1 T2 को ट्रिगर करना है. This is T1 T2 ट्रिगर कर दिया मैंने. When T1 T2 is triggered, then T3 T4 will off here now. लेकिन करंट कैसे जाएगा? Current will not go to T1 T2. Now the current is going opposite direction में ना इस डायरेक्शन में जा रहे हैं नेगेटिव डायरेक्शन में. So वो वाला ICRs कहाँ वो वाला डायोड्स कहाँ मिलेगा? So this is how the current was going. तो अभी क्या करना है इसका काउंटर पार्टनर कौन है देखना पड़ेगा. अपोजिट डायरेक्शन में डायोड जाना चाहिए इसी डायरेक्शन में डायोड जाना चाहिए. For that look at 1 and 2. Look at 1 and 2. So if you look at 1 and 2 current will be look at this one. This will go in direction तो वही है 1 में जाएगा वापस 2 में आएगा. This is how. So this one is I can say 1 and 2. Basically again the same thing whatever we have obtained here. T1 T2 again it increases T1 T2 here now. Of course now you can extend this क्योंकि अभी पता चला हमको ये वाला पार्टनर कौन कंडक्शन में जा रही है. इधर देखो कौन है इधर नीचे है ना नीचे is D1 D2. So what I am saying here now and this is how it continues and this is how it continues. So RL load है जब RL load हुआ उस समय thyristor T1 T2 or the T3 T4 or the switches not starts from here 0 here now can see it conducts here now T1 T2 D3 D4 है. So एक साइकिल में half it means the 50-50 you can see here now. Previously क्या किया from here hit positive cycle entire positive cycle T1 T2 अभी T1 T2 and D1 D2 तो शेयर कर रहे हैं. Now I have one doubt here इधर आपने इधर T3 T4 को ट्रिगर कर रहे हैं लेकिन T3 T4 क्यों ट्रिगर नहीं हो रही है? T3 T4 को मैं बता रहा हूँ T3 T4 को ट्रिगर कर दिया इधर. So why the D3 D4 or why the T3 T4 are not getting on? आपने T3 T4 को ट्रिगर कर दिया इधर तो ठीक है मुझे कुछ दिक्कत था इधर. सो कंडक्शन के लिए नेगेटिव करंट ACR नहीं जाएगा इसलिए इधर D1 D2 कर लिया. इधर क्यों है इधर तो पॉजिटिव है. सो T3 T4 why it is not on? क्योंकि T3 T4 इधर है ना क्योंकि D3 D4 कंडक्शन में जा रहा था ना D3 D4 में कंडक्शन में when this is conducting so plus here minus here so plus here minus here इसका बीच में वोल्टेज ड्रॉप होगा. The drop in diode which makes the ACR reverse biased. Because of that when D3 D4 are conducting T3 T4 will never get turned on. Similarly the case when D1 and D2 are conducting मतलब इधर प्लस है इधर माइनस है ये वाला कंडक्शन में जा रहा था उस समय इसके बीच में वोल्टेज ड्रॉप होगा which means that there is a voltage negative voltage across the SCR which is reverse biased. That is the reason it won't conduct. Okay, so please write down this point here now. Even though T1 T2 are gated The gated means gate signal there. Even though T1, T2 are gated, at t equal to 0, these SCRs are not turn on. These SCRs are not turn on. Because these are reverse biased by voltage drops across D1 and D2. These are reversed biased by voltage drops across D1, D2. Okay. Similarly, if it is RLC, overdamped, underdamped. So if it is RLC overdamped is equivalent to RL load, same thing. I'm just trying to draw here now. I0 this is for RLC overdamped. We'll see in the networks case, RLC overdamped means equivalent to almost RL load only. So the scenario will be same as what we have seen. So we'll see the same thing current, but it's a little bit kind of wavy, is not just rectangle, it's more kind of sinusoid, little bit. The scenario is same here. T1, T2, D1, D2, D3, D4, T3, T4. Another one, this is asked in examination once. RLC underdamped. This is equivalent to a kind of RC load. RLC underdamped is equivalent to RC load. Now it is equivalent to RC load means current has to lead the voltage. So what will happen here now? In this case, current leading, eh? So look at this portion. This is how it's happening. इधर T गया, current आ गया. At T equal to 0, yes, T1, T2 positive, T1, T2 conduction में हो गया. T1, T2 इधर देखा कैसे बंद हो गए. Current is becoming 0. This is called as a natural commutation or load commutation, rather I would say. We have something called as a load commutation. Load is making the load, RLC load, underdamped load, the current waveform is such that current is becoming negative. तो क्या हो गया? SCR will not allow the negative current. SCR extinct हो जाएगा. SCR बंद हो जाएगा. अगर SCR में holding current से कम current उसमें गया तो it will get turn off, or the SCR is having a holding current, it will get turn off. So ये वाला 0 आ गया तो T1, T2 बंद हो गया. लेकिन क्या है, दिक्कत क्या है इधर? T3, T4 हमने ट्रिगर कहाँ कर दिया? T3, T4 को इधर ट्रिगर कर दिया. लेकिन इससे पहले ये दोनों में ना कौन कंडक्शन में जाना चाहिए? From here to here, and who is the one which is going to conduct? पॉजिटिव करंट जाना चाहिए. T1, T2 कंडक्शन में जा रहे. लेकिन बिफोर T3 T4 आर ट्रिगर्ड ड्यू टू लोड, ये दोनों बंद हो गया, करंट हमको कंटिन्यूस आना चाहिए, एसी करंट आना चाहिए, अभी कौन कंडक्शन में जाएगा, ये तो बंद हो गया। T3 T4 ट्रिगर कर दिया तो तुरंत T3 T4 आएगा, लेकिन T3 T4 ट्रिगर नहीं किया, उसका शेड्यूल बाद में है, इधर नहीं आएगा, इसका पीरियड में इस डायरेक्शन में जाना चाहिए ना, then the current will be going here now, look at here now, negative current, it is going negative, so negative current means D1 D2, it's a negative current means D1 D2, so D1 D2, only one thing here, first 180 period में small total 360 है, 180 में कौन शेयर करना, 1 T1 T2 D1 D2 शेयर करना पड़ेगा, that's what happening here. Similarly here also, once this become here, now this is a negative current and up to here, right? So last one, so look at this, this is mono pi or 2 pi, that's what you can consider. T1 D2 है, इधर तक कौन जाएगा, कंडक्शन नेगेटिव करंट है, इसी डायरेक्शन में जाना चाहिए, ट्रिगर किसको कर दिया मैंने इधर, as soon as T3 T4 ट्रिगर कर दिया उसी डायरेक्शन में जाएगा, so this is T3 T4, लेकिन T3 T4 इधर बंद हो गया, पॉजिटिव करंट है, अभी कौन है, T3 T4 ऐसा जा रहा है, अभी पॉजिटिव करंट आएगा तो ये डायरेक्शन में जाना चाहिए, कौन कंडक्शन में जाएगा, D3 D4, D3 here now, so this is D3 D4, and similarly here now T1 T2 and D1 D2, like this it starts going here now. So in RLC under damped mode, I was saying that there is a load commutation, so please mention that point. In RLC under damped load, T1 T2 R, T1 T2 R is naturally commutated, which is called as a load commutation. Naturally commutated, which is called as load commutation. Similarly, T3 T4 also naturally commutated. Okay, one thing I would like to mention, voltage waveform, there is no change. Voltage is always that rectangular form will be obtaining. We have seen the Fourier series also for this yesterday I had one, which is important, harmonic side. हमारा इन्वर्टर में ऐसा वाला वेवफॉर्म बाहर आए तो दिक्कत है यार, इसलिए normally we'll keep the filters. We use the filters to take out the harmonics, right? So let us see the three-phase one, very important one. Three-phase may how the three-phase is produced here now. Okay, so three-phase voltage or the three-phase current is appearing here now. Before that, can you just see the one problem here? Single phase में एक problem कर देना. A single phase full bridge inverter. Single phase, write down single phase full bridge inverter. Source voltage Vs 230 volt DC. Load consisting of RLC, find the power delivered to load the load due to fundamental component. Find the power delivered to load due to fundamental component. Power delivered to the load due to fundamental component means RLC load है हमको power कौन लेगा यार? Only two fundamental component. Real power will take only by the resistor. हमने बताया power electronics में हमको बता दिया पहला क्लास में average power consumed by inductor and capacitor is 0. So it won't take any power. So V01 fundamental component V01 square V square by R. What is V01 here? Fundamental component of voltage. How do you obtain the voltage here now? Output voltage. V0 output voltage is a V01. We get a alternating. So this is Vs minus Vs and Vs. Okay? Fundamental. इसमें the harmonics है. I told you already how to get the this one. Fundamental means you remember the harmonic one 4Vs by n pi, right? So that one I have to take it here now. What is that value here now? So look at the fundamental component or the harmonic which I have written there, harmonic analysis. This is sigma 1 equal to infinite 4Vs by n pi sin n omega t. Do you remember that? So V1 चाहिए. V1 कितना होगा? This is instantaneous value 4Vs by pi sin omega t. इसका RMS value से V01 Vm by root 2. That's all. Get me this value 4 Vs is 230 3.14 1 by root 2. Then you substitute here now R equal to 1 anyway, whatever the value you get, that is the power delivered to it. So how much that is? 20207, that's correct. Okay, yeah. So then 42 V01. So 4 Vs by pi 1 by root 2. Okay. One thing I would like to mention here now, yes, fine, but this voltage, V01 voltage, is a total voltage on the output side. RLC, may please understand here now. There is another way here now, RLC. Whatever the voltage applied across this one is total voltage. Rather than taking the V01, it is good to take I01, मतलब current. अगर मान लो आपने total voltage लिया तो separately resistor में voltage लेना चाहिए. So what should I do here now? Rather than using ये वाला total voltage है, ठीक है, voltage निकाल सकते हैं, no issues there. So but actually the power delivered only to the fundamental component, power delivered only to the resistance means current निकालो, I square R. So which I am writing here now, I square I01, क्योंकि series elements है, current निकाल सकते हैं, I01 square R. लेकिन I01 कितना है? I01 कितना? I can have it here now. RMS value. This is RMS value. Please understand. RMS value is V01 total value by R. So how much this one is obtaining here? So current will be RLC1. We don't know. The current is leading or lagging. Yes, definitely leading. You like XC ज़्यादा है ना? So I can say here now instantaneous I01 can be written as, I'll directly write it here now. Instantaneous I01 can be written as capital I01 is a RMS value into root 2 is a maximum value sine of omega t plus phi. Definitely this is leading क्योंकि XC ज़्यादा है. XC is greater than XL, so it's a leading in nature. And I01 root 2 I01 क्या है मैंने बता दिया. I01 is V01 by R. What is the V01 R? 207 by root 2 sine of omega t plus phi. So this get cancels out. This is 201 sine omega t plus phi. I01. So your IM is 201. This is actually IM is 201. So I can make here now 207. 207 by root 2. क्योंकि RMS है ना, IM by root 2 whole square into R. This is the one actually. So it comes around 21 kilowatt. So करना क्या है इधर, मैं बता रहा हूँ क्या हो रहा है इधर. टोटल वोल्टेज है ना, इसमें टोटल वोल्टेज है V. I cannot take the V01. Rather, there is another way also. You can take it if you want. VI, V into PS equal to V into I. Then we can take average value of fundamental component of that. That way you can take it. Otherwise, you can have a I01 because the same current will go fundamental component current into R. ये fundamental component कैसे मिलेगा? So this is the instantaneous value लिया मैंने. This is the one. I01 is RMS component which I mentioned into root 2 is a maximum value. लेकिन I01 is V01 by R. V01 by R is this one. It cancels out. And then total RMS value 207 by root 2 whole square into R, I square R. So that's a 21 kilowatt. Let us move on to the next one. Is three phase. Meaning three phase कैसे हमको बाहर आएगा, DC इनपुट से थ्री फेज आउटपुट कैसे आएगा. So inverter internal structure क्या होगा? Simple here. Whatever the single phase may we have, such kind of setups will be three. For example, let me show it here now to you. It's a big setup. This is how 3 setups will be there. And of course I have to give a VS voltage supply. Where is the load connected? Let me naming it. The naming is such that we have taken some AC to DC convert में कैसे naming दिया? The same way, because sequence will come for us 1 2 3 4. You can give whatever the naming, but this naming will make us to remember the sequence easily. 1 2 3 4 and 5 6. This is how we have taken AC to DC also in converters. Similarly, diode को भी. Now where is load connected here? Load is connected. This is one A phase, one phase. You'll get the output. Let me take out this. And here you'll get one more voltage. Let me take out here. Here one more voltage. You get it. Let me take out this here. All this comes here. And there is overall load. This is the load. Now how the three phases obtained here. First, first one thing is we have something called 180-degree mode. What do you mean by 180-degree mode? Means एक लेग में दो ACRs है. Each ACR will conduct for 180. Total 360 है ना? उसमें 180 share करेगा. So it is in our hand based on the triggering. So meaning, let me show you for you, then I'll draw the waveforms. Okay. Three phase, one more I wanted. Okay, first leg में 1 and 4, one is 180-degree, so मान this is 180, and second 180 here now. So this is 180 and 360. So the total 180 here now. T1 will conduct for 180, then T4. ये वाला B phase है ना? B phase करना क्या? T3 कहाँ ट्रिगर करना? 120 के बाद, क्योंकि हमको sin ओमेगा T, B phase sin omega T 120 के बाद आना चाहिए. Look at here now. This is the voltage I wanted. So ये वाला phase, पहला वाला phase, second phase में 120 phase difference होना चाहिए. Then what I do, I'll trigger T3 after 120. So this is 120. ये बात समझ में आ गया? This is 120. I'll trigger what? T3. T3 at 120 trigger कर दिया, लेकिन कितना conduction में जाना चाहिए? 180 degree. So this is I was discussing about. I have mentioned 180-degree mode. 180-degree mode. So T3 180 conduction में जाना चाहिए, मतलब कहाँ तक? 120 plus 180, 300. इधर तक जाएगा. उसके बाद काउंटर पार्टनर कौन है? T3, T6. So T6 will conduct here now another 180. So which is somewhere here 480. You got this point? Did you understand this point? Of course, this is T1. Next one is 360 up to this one. 360 plus 180, how much? 540. And it's keep on going. T4 and here T3. Did you understand this point? What I have drawn? पहले 180 डिग्री मोड़ है. SCR को हमको ट्रिगर करना कि ये वाला 180 में चालू होगा, 180 डिग्री कंडक्शन में होगा, ये 180 डिग्री कंडक्शन होगा. सो पहले T1 180, T4 180, T1 180, T4 180. Like that it will go. लेकिन this is B phase. B phase में हमको 120 डिग्री लैगिंग होना चाहिए. So लैगिंग के लिए मतलब आप ट्रिगर करना T3 को after 120 डिग्री करना. T3, T6, T3. What is this one then before? What is this guy? T3, T6, T3. T3 से पहले कौन है? इधर कौन होगा? Who is the one which is conducting? Should be conducting. Which guy should conduct here? Are you there, guys? Which guy should conduct? Yeah, that's correct. So here this is T6. Fine. Next, B phase, C phase. VC, VM, sin omega t 240. 240 मतलब after 240. T5 को trigger करना. So 240 मतलब somewhere here now, that is 180. This is 240. 240 plus 180 here now, somewhere. So how much is this? 420. So somewhere here up to this place. 420 तक who is supposed to conduct? Is T5. उसके बाद next 180. Next 180 means how much? 600. So up to this one, who is T2. So that's how we'll be conducting. So इससे पहले कौन कंडक्शन में जाना चाहिए? इससे पहले वाला पहले मतलब 240 है ना, नेक्स्ट प्रीवियस 180 है. So T2 में जाना चाहिए कहाँ तक? 240 minus 80. So where is that? 60. So 60 तक that guy will conduct. This is 60 point. 60 से पहले T2 से पहले who is the one? T5. So this is up to 60. Who are all conducting here now? Tell me now. हमको आ गया अभी 60 तक, 120 तक, 180 तक. Every 60 conduction is changing. Can you tell me then who are all conducting here now? Omega t is between 0 to 60. Who is conducting here now? 5, 6, 1. Do you agree with me? T5, T6, T1 should conduct. Next, omega t 60 to 180. Who is conducting? 60 to 180 में 5 तो हो गया. 6, 1, 2. Do you agree with me? T6, T1, 2. Next, omega t 180 to 180, 120 to 180. 120 to 180 means from here to here. Who is there? You can see 120 मतलब कौन बंद हो गया? T6 का कंडक्शन बंद हो गया, बाकी तो बचा है, तो किसका है? T1, T2 और T3 सीक्वेंस में आ रहे हैं. Did you observe? 5 6 1 6 1 2 1 2 3 1 अभी बंद हो जाएगा, 1 का कंडक्शन at 180 में. Next conduction, this is how every 60 degree the conduction will be like this, every 60. So I'm saying 5 6 1 6 1 2 1 2 3 2 3 4 and 3 4 5 and 5 6 1, and again it repeats every 60. 1 2 3 4 5 1 2 3 2 3 4 3 4 5. This is 4 5 6 is missing. Then 5 6 again repeats. So do you understand how the conduction is happening? So this is one set 60 degree के लिए, another set 60 degree के लिए, another set 60. This is 60 and 60 here now 60. 6 60s are 360 degree. 360 degree conduction हो गया. And then SCRs, each SCR conducts for a period of 180, but 3 set of SCRs conducts for a period of 60 only. Then the combination is changing. ये वाला बात समझ में आ गया या नहीं, बता देना प्लीज. Did you understand guys the point which I discussed here now? इधर देख के मैंने लिखा 60 तक 5 खत्म होगा, 60 तक 5 6 1 चालू में होगा. Do you understand this point please? ये बात समझ में आ गया आपको? Yes or no? I want to draw the V naught. V naught अभी 5 6 1 कंडक्शन में गया तो लोड अदर 5 6 मतलब 5 इधर है, 6 इधर है, 1 इधर है. So 2 top SCRs, 1 down SCRs. Every time what happens is 2 SCRs from one group, 1 SCR from another group, or 2 SCRs from down group, 1 SCR from upper group. No 3 SCRs of upper group will conduct. ऐसा कभी नहीं होगा. ये वाला समझ में आ गया या नहीं? Are you there guys? Can you hear me first of all?
Yes sir.
Okay fine. So is this understand or more clarification needed? ये समझ में आ गया या फिर more clarification चाहिए?
सर एक बार और समझा दीजिए.
Okay साहू, okay cool. मैं ये बता रहा हूँ कि 180 डिग्री का मोड़ है ये वाला. मतलब इसका मतलब क्या होता है, ये एक लेग में ये वाला एक सेट है ए फेज का, ये वाला बी फेज का, ये वाला सी फेज का. हमारा पर्पस क्या है? डीसी वोल्टेज को 3 फेज सप्लाई, 3 फेज आउटपुट आना चाहिए. ये वाला डीसी है, सो इनपुट है, इधर आउटपुट क्या आ गया, हमको 3 फेज सप्लाई आना चाहिए. कैसे आ जाएगा? 3 फेज आना चाहिए ना. एक लेग सिंगल फेज है, सेकंड फेज, थर्ड फेज. मैं ऐसा ऑपरेट कर रहा हूँ कि 180 डिग्री कंडक्शन जाएगा, 4 180 है तो 1 4 1 4 लिखा, 180 180 180 करके. दैट्स हाउ आई एम ट्रिगरिंग. A phase will start at omega t equal to 0. This is omega t equal to 0. B phase मतलब ये वाला B phase है, कहाँ चालू होना चाहिए? Look at the waveform. This is the one, right? A phase is here, VA, and VB phase. B phase कहाँ आएगा? 120 डिग्री के बाद. This is our B phase. इसलिए B phase corresponding SCR को मैंने 120 के बाद ट्रिगर कर रहा हूँ, T3 को. Look at here now, 120 के बाद ट्रिगर कर रहा हूँ मैंने, तो आपका B phase वोल्टेज आ जाएगा. लेकिन T3 T4 ये वाला 360 में जाना चाहिए, इक्वल डिवाइड होगा 180 180. सो T3 180, 120 प्लस 180, T6 180 में जाएगा. हो गया काम. उसके बाद हमारा C फेज कहाँ है? VC. दिस इज VC. 240 240 के बाद चालू होना चाहिए, क्योंकि ऐसा वेव फॉर्म चाहिए ना हमको. इसलिए C फेज वाला SCR को मैंने 240 के बाद ट्रिगर कर रहा हूँ. मतलब 240 इधर है, ओमेगा T, तो T5 को ट्रिगर कर दिया. लेकिन कहाँ तक कंडक्शन में जाएगा ये वाला? कहाँ तक? मतलब मैक्सिमम 180 डिग्री कंडक्शन जाएगा. 240 प्लस 180 420 तक जाएगा. देन T2 आ जाएगा. ठीक है, ये तो सीक्वेंस बन गया. तो पीछे कर SCRs लिखा. नाउ सी द सीक्वेंस. हु इज कंडक्टिंग हियर नाउ? दिस इज 180, दिस इज 120, दिस इज 60. सो पहला 60 कॉम्बिनेशन में कौन कौन कंडक्शन में जा रहे? पहला 60 कॉम्बिनेशन में बेस्ड ऑन दिस पिक्चर 5 6 1. At 60 it is getting off. So who should come? C phase में this is for A phase, this is for B phase, this is for C phase. C phase में अगर T5 नहीं तो T2 डालना है. T5 बंद हो गया तो T2 आएगा. तो अभी क्या होगा? T6 T1 ऑलरेडी कंडक्टिंग, T6 T1, सभी T1 आ गया, नया चीज. ठीक है, कहाँ तक जाएगा? 120 तक. T6 बंद होगा. T6 B फेज में कौन है? T3 का होगा इसका ड्यूटी. अभी T6 आएगा और T3 आएगा. T3 आ गया. So then the sequence will start. Is that clear, guys, now? Sahu?
Yes, sir.
Okay, now I want to draw the waveforms here now. V0 में मैंने बता दिया, at any instant only 3 SCRs are conducting. So please mention these things here now. In 180 degree mode, each SCR conducts for 180 degree of a cycle. Each SCR conducts for 180 degree of a cycle. Okay. And at any instant, 3 SCRs conduct. At any instant, 3 SCRs conducts. Two from upper group, one from lower group, or vice versa. At any instant, 3 SCRs conducts. Two from upper group, one from lower group. Or vice versa. Vice versa means दो नीचे ग्रुप से आएगा, नहीं तो वन ऊपर ग्रुप से आएगा. Remember the sequence 5 6 1 6 1 2 1 2. Easy to remember, right? 5 6 1, 5 हट जाएगा, 6 1 2 आएगा, उसके बाद 6 हट जाएगा, 1 2 3 आएगा, इसके बाद 1 इधर से हट जाएगा, 2 3 4, ठीक है। That way until we get the same 5 6 1. इधर 5 6 1 आएगा, 6 6 kind of things. Okay, I remember the sequence. I'll erase this portion. I remember the sequence now. Now I want to show the voltage waveforms here now, how it comes to you. Shall I move on, guys?
Yes, sir.
Okay, cool. ये वाला चाहिए, ये वाला पिक्चर लेफ्ट साइड वाला चाहिए सर्क्यूट, इसलिए वैसा रखा मैंने। First one, T5, T6, T1 conduction में how this will happen. Let me show you this one. This is for A phase. This is for A phase, as I mentioned. This B phase, this is C phase. Okay, let me draw that, please. 5 6 1 conduction between period of 0 to 60. 5, where is 5? Which means that 1, T1, T3, DT, all are kind of off. Okay, first one I'll show this anyway to you. All switches. Okay, fine. I hope you understanding this. Only this is conducting. Rest of the things are open. 6 1. T 5 and 1. 5 and 1. 1 also is there. 5 and 1. 6 from the down group. Let me open first, then I'll draw. 6 ka high. This is the 6 1, 6th down. So how the load I'm connecting here now, load मैंने बाहर लेके आ रहा हूँ, एक इधर से दूसरा load from here and तीसरा from here. So 3 phase है ना, this belongs to A phase, this belongs to B phase, this is C phase. मान लो some impedance है, I'm taking some, ये वाला star connected, just like for example I'm taking a star connected load. So your load is connected and your load is connected. This is a neutral point. समझ में आ गया? This is Z, Z, Z. Do you understand this 3 phase load? This is what I have written. 3 phase load. A phase, A phase, B phase, C phase, Z, 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 ये वाला neutral point. समझ में आ गया ना वाला? You understand this point?
Yes,
Okay,
sir.
fine. Okay, cool. How the current, so look at this is Vs. The current is SCR and SCR anode to cathode में आना चाहिए. Anode to cathode. So the current is going from this T1. Okay, current will come here now this way. And positive SCRs they come. And the T5, so current is coming to T5 in this direction, positive direction. And both the current will come like this. Okay, please understand. ये वाला current इधर आएगा. Then what will happen here now? How the current is going? A and C current are coming inside from, this is say मान लो A phase here. This is C phase, A and C positive current. And both the currents are coming, going out to this SCR. SCR नीचे वाले ना T6. T6 मतलब anode to cathode. So इधर जाना चाहिए. Then कहाँ जाएगा? To the source. Do you understand what I have drawn here now? Did you understand the point? बाहर से करंट आएगा, एनोड टू कैथोड करंट आएगा, ये वाला चालू है तो करंट इसमें तो लोड में जाएगा. सिमिलरली करंट इधर जाएगा ऊपर वाला to the load. Both the currents come here now. So this B phase, this is actually B phase, will go up to the SCR, down SCR to the load. ये वाला बात समझ में आ गया, please? Did you understand, guys?
Yes, sir.
Good, cool. Let me draw. I want to take out all this nonsense. जो भी open कर दे इसको जरूरत नहीं. I would like to take out that. Let me draw the scenario here. So don't you think this Vs is connected to A? Vs is connected to C is connected to this one. Do you agree with me? So can I see? I'm redrawing it. Simple to redraw. This is the source voltage Vs. Who is connected to the source voltage? Vs को कौन connection में जा रहे? Can I say this Z, which is A phase Z? So this is A phase Z is connected. Do you agree with me? ये वाला सीधा source को connect है. Do you agree with me? Yes or no? सीधा source को connect है. Yes? Yes or
Yes, sir.
nice. And the next one, कौन सा वाला सीधा ये source को connect है? कौन सा वाला है? कौन सा phase वाला? This is the one. Who is this guy?
C.
Excellent, guys. C is connected here now. Both are joined at one point. This is a neutral point or O. Anything you can call neutral or O. This is C phase. This is Z. C phase के बाद ये वाला NR0 वो इको resistance है, impedance Z. ये वाला कहाँ जा रहा है? सीधा किसको connection है? This impedance will go and connect to where? Where it is connecting?
Source negative.
Source negative. Excellent. Can I draw this way, boss? Is it fine? And this is B phase. Are you with me, everyone? Is it clear?
Yes, sir.
Okay, cool. Now I want to get the voltage 0 to 60 period mein A phase VAO. This is VAO. Then this is VCO here. And this one is here now VOB. O is on the top, neutral V and B. समझ गए बात? So क्योंकि positive connection. So what ZZ parallel, and this is Z. Yesterday I was discussing about the voltage division, series parallel combination. इन दोनों में क्या होगा? So this will be Z by 2. This is, and A C O here now. and this is Z, and this is O and P. Voltage is Vs. Get me the value here now. Voltage division use करना है. So VAO or VAN or VAO, VAN which is equal to VCN, dono VAN or VCN which is equal to, what is the voltage here now? Vs into voltage division. Vs into इसका impedance upon sum of these two impedances. Z by 2 by Z by 2 plus Z. So this becomes here now Vs Z by 2. This is Z 2Z 3Z by 2. 2 get cancels out. And you're remaining with Vs by 3. Do you agree with me? Yes or no, guys? VAN VCN equal to Vs by 3. So इधर कितना वोल्टेज आएगा? दोनों में Vs by 3 आएगा. इधर कितना आएगा? Plus here minus here. This is what is this? VOB. कैलकुलेट करने की जरूरत नहीं है. टोटल VSI KVL में Vs by 3 आता है. इधर कितना होगा? How much this is, guys? 2 Vs by 3. टोटल Vs by 3 है ना. ये दोनों ऐड करो. Vs आना चाहिए. VOB or VNB. Don't, I mean, sometimes I'm using O, sometimes neutral. Don't get confused. Actually, O neutral point or N is both are same. Or you can use VNB. VNB is 2 Vs by 3. What is VBN? I want VBN. Minus 2 Vs by 3. Did you understand this point, please? I want to draw the A phase, B phase, C phase waveform. 0 to 60 में VA and VC are equal of a magnitude V by 3. VBN has a magnitude of minus 2 Vs by 3. Did you understand this point, please? ये बात समझ में आ गई आप लोगों को, please?
हाँ सर.
Okay, cool. Let me take the other one. Other 62, 120. Now this time we can directly move on because you understand this portion. So when two are parallel, V1 by 3 is the voltage, Vs by 3 is the voltage. Other one is 2Vs by 3. Who is the next group of SCRs conducting? 60 to 120 में कौन conduction में है? Who are all the SCRs conducts? Who are all the SCR conducts in 60 to 120?
361 T2 sir.
Excellent. 612. क्योंकि 5 का टाइम हो गया तो 560 तक के कंडक्शन में जाएगा. नेक्स्ट सेट आएगा 612 आएगा. 612 मीन्स 612. सो अभी नीचे का SCR 2 होगा, ऊपर का SCR 1 ही हो गया. ऊपर वाला पॉजिटिव है, नीचे वाला नेगेटिव आएगा. सो व्हाट आई एम डूइंग हियर नाउ, 1 is A phase, 6 is B phase, 2 is C phase. Can I draw now, having said that these two are parallel, right? Niche, wherever the two are there parallel. Can I draw something like this here now? I'm erasing this portion and I'm also erasing this one. So it's easy to draw also. T6, T1, 2. So 6 and 2. 6 and 2 are B phase wala. And this belongs to B phase, T6. 2 belongs to C phase. 1 belongs to A phase, right? This is the upper group. Upper group. Can I draw? Upper group is always positive. Can I draw this way? Directly I'm drawing here. Meaning this is upper group all positive, and so this is A phase. This is neutral. And another one is B and C. Do you agree with me? Based on the previous experience, I'm drawing like this. Do you agree with me or not? Yes or no?
Yes, sir.
These conducts, both are negative. So then what will happen? VAN, voltage division. VAN, I can directly write. इसमें ज्यादा होगा 2Vs/3, same as this one. Single one में ज्यादा होगा, parallel combination में कम होगा क्योंकि कम resistance है. Now VBN, VCN, which is equal to minus sign. नीचे वाला minus sign है. Minus Vs/3, like what we have seen. Either B negative, BNB is positive. VBN is negative. We want the B phase, VBN. ये समझ में आ गया? Did you understand this? 60 to 120. Now, if you understand this, can you tell me the next one? 120 to 180. And who are all conducts?
1 to 3.
Yes, excellent, Sahu. It's 1, 2, 3. Nice. But what is the voltage? A phase, B phase voltages. So I was saying here now, that's cool. As you guys mentioned, omega T is, this is 1, 2, and 3. 120 to 180. Conduction is T1, T2, T3. 1, 2, 3. 1 is A phase, 2 is C phase, niche. 3 is upper B phase. Do you agree with me? A, B, C. 1 A phase, 2 is niche wala C phase, 3 upper B phase. If it's lower or upper, this group is completely A phase, completely B phase, completely C phase. Now tell me 1 and 3 odd numbers positive. 1 and 3 मतलब अभी कैसे लिखना चाहिए? How this will be now? Can I draw? What are these one phases? Can you please tell me now? If you understand, you'll tell this. Both are parallel. 1 and 3 are parallel. So कौन सा phase वाला है? क्या लिखना है इधर? कौन सा phase है इधर? दो parallel है. 1 and 3 parallel है. 1 and 3. कौन सा phase है? A and A क्या है?
B, sir.
B, excellent. A and B neutral. This is C. Now the voltage is, if you understand one calculation and पूरा जो भी आ रहे हो तो आसान है. VAN, which is equal to VBN, Vs/3 voltage division, VCN नीचे वाला है minus 2Vs/3. Are you guys clear with this? Now let me show the waveform. Please, VA का waveform अगर देख लिया तो VA 60 Vs/3 आ गया, 120 में 2Vs/3 आ गया, 180 तक Vs/3 आ गया, and correspondingly will be obtaining. You can calculate up to 360. 360 तक आप calculate कर सकते. Then I would like to draw the waveform here now. Shall I draw the waveform now? Similarly, you can calculate. I want to draw the waveform here. I'll show you. 180 तक जो भी draw कर दे दिखाता हूँ आपको. See the wave phase values. A phase. This is VAN. VS by 3, 60 में, 120 period में, and 180 period में, 120 to 180. I need to draw these two values. Similarly for B phase and similarly for C phase. So there is a gate question here. इसलिए we are going in detail about this. Is it clear? Just copy that one. I would like to draw the waveform here. So let me draw that. You remember these values, please, anyway. How the three phase is obtaining, let us see. Outputs. So tell me this VAN up to 60. What is the value? VAN, VS by 3, right? Just showing here now. Omega T is 0 to 60. Then 2VS by 3. 60 to 120. Next, VS by 3. Omega T is 120, 180. Do you agree with me?
Yes, sir.
Nice. So let me show that here now. I'm showing this as VS by 3 up to 60. Oh no, this is 60, 120. VS by 3, 2VS by 3, again VS by 3. At 180 here now. Okay, then I'll come to that 180 to that period. B phase me. What is the VBN value? VBN is minus 2VS by 3. Just check that, please. 60 degree up to 60 degree. VBN equal to minus VS by 3. 60 to 120, and this is Vs by 3, 180. We have already obtained, so I'm just drawing that. So minus 2 Vs by 3. Minus 2 Vs. 60 to 120 minus Vs. 120 to this. This is the one. Do you agree with me? Minus 2s by 3, Vs by 3 minus, and this is Vs by 3 plus. Do you agree with me, guys? Is that clear?
Yes, sir.
Next one. VC1, VCN. We have seen Vs by 3. Please validate this. 0 to 60. And C is minus Vs by 3. We have just now calculated this. And then minus 2Vs by 3. 120 to 180. You please calculate this one. So 60 Vs by 3, 60 to 180 minus Vs by 3. 60 to 180, is it minus 2 Vs by 3? Like this will draw. And even up to 180 the calculate karte, even 180 to 360 also we can calculate. The waveform will be same. This pattern repeats in the negative sign. So which means here now this is 240, 300. The pattern is like this here. Again it repeats. That's what the same pattern is going to. Actually, it is easy to remember also. Then what will happen is next one. Let us see here now how what we can do. This one 240, 300, 360. Actually 120 delay karo. अब 120 delay करके इधर 120 है ना. This is the waveform. A phase waveform आ गया 360 तक. B phase waveform वही होगा लेकिन 120 delay करो. So that's look at here now. Step up, up, down, down, up, and this is the waveform. 120 मैंने चालू कर रहा हूँ इधर. 120 lagging है. So the same waveform I'll be drawing. That's all. This is how the waveform get repeats. And here also same thing. Same waveform will repeat after 240. 240 matlab from here. You start from here. 240 mein same waveform. Easy to remember. Need not find the things. Right up to here and get increases and down 360 tak aayega. Then here and like this it will go. And we can finish this way. We have already done from up to 180. 180 तक calculation करते हैं. मैंने उसके बाद दिखा रहा हूँ actually how this will look like. 120 like this and 240 from 240. 240 से पहले कैसे? That's how this will be. You can see, you know, this is end up. So 240 se pehle. So which means that this is the portion. Actually, this is how it will be. No need to worry about this. You can just remember the waveform is like this. And there are some conclusions, calculations somehow we can obtain here now. Having said that, here 1 volt line voltage, this is phase voltage. 1 voltage VAB, which is equal to VA minus VB, or rather VAN minus VBN. अभी बता देना यार इधर VAN minus VBN कैलकुलेट करके बताओ. VAB ड्रॉ करना है. I want to draw the VAB. Tell me now. 0 to 60. 0 to 60 क्या होगा? Tell me. VS, this is VS. What is this value? VS by 3. 2S by 3. VS by 3. So what will happen? VS by 3 minus of 2VS by 3. What is this value? 60 tak. Tell me one by one, please. You do the difference and tell me the value. 180 and 120 tak. And 240 and 300. Very important point I'll be obtaining here now. And tomorrow we'll do the Fourier series analysis for this. Now I want this. VAB kya hai? VA minus VBN. So what is this one? VS by 3, 2VS by 3. Do you understand, right? 0 to 1 by 3 minus of 2 by 3. Yeah? How much this is? How much this is? This is what I am saying. VS by 3 minus. What is this value? VS. So 0 to 60, it is VS. 60 to 120. 2VS by 3 minus of minus VS by 3. How much? How much is this? Is there no difference? Guys, are you there?
Yes, sir.
Okay, fine. Nice. So let me draw that here now. Difference VS by 3. 2VS by 3 minus of minus VS by 3. What is this? VS. Just subtract karo. This is VS by 3 minus VS by 3. 0. A and B ko subtract karna, magnitude ko, that's all. 180 240 minus VS by 3 and 2VS by 3. So how much is that? Minus here minus VS and 240 360 minus VS. So VS minus VS. Again the same thing repeats. 300 360 there is a gap. Again it get repeats. So every 120 120, this is 120 and there is a gap of 60. This is how the waveform here, VAB. So I want to do the Fourier series for this also. Please look at once what we have drawn and please understand one thing. हमको alternating आया, हमारा voltage DC है input में, अभी output में क्या है? Alternating आया, लेकिन ये वाला साइन नहीं है, साइन वेवफॉर्म नहीं है. तो क्या करना? साइन वेवफॉर्म नहीं तो क्या होगा? हार्मोनिक्स होगा इसमें. So what are those harmonics we have to see? Just go through once here. So go through once and anything you need help in understanding, and Amit and Manjusha. So just let me know. So if you don't have anything, I think that's fine. So we can wind up the session. If you have anything, just let me know. And guys, other guys also. Okay. Okay, Saho, then good. Okay, yeah, thank you, Sabu. Thanks. Yeah, thank you, Manjusha. Thanks.